John Bloom here from Jibo. Can you hear me okay? Just type in if you can hear my voice. Nice. All right. So like I said, my name's Jonathan Bloom. I'm a voice user interface designer for Jibo. And you may ask what a voice user interface designer does. And hopefully over the course of this presentation, I'll be able to explain that. But you can already imagine it has to do with voice and speech and talking to machines. So I thought I'd give a quick explanation of how I got into this field. You might find it interesting. When I was an undergrad, I was fascinated with how people used the word like. And for a psychology class, we had to pick some topic to discuss, and I decided to look at how people use the word like, or overuse like, as some people might think. So I interviewed a whole bunch of students and put them under pressure situations and non-pressure situations to try and get an idea of how people vary that. And it was really fascinating, and I realized at that point I wanted to study language and the psychology of language for as long as possible. So I ended up finding out that there was a burgeoning area in the late 90s called voice user interface design, which allowed me to work in speech but also in technology, which I also enjoyed, and worked at Dragon Systems back in the 90s and went from there. So here I am at Jibo, and we're going to talk a little bit more about voice user interface design and also social robotics. So, subject is designing voice user interfaces. And maybe we should define our terms first. So you might ask, what is a VUI? And I tried to come up with a definition that is as large as possible and all-encompassing because there's so many flavors of VUI. So simply put, it's a method of communicating with computers by means of spoken language. Right? So you can think of many ways that information can be input into a computer and out. Right? You could use a mouse to input, you can type, you can tap on a screen, and in terms of output, you could see things visually displayed, you could hear some sort of nonverbal audio, but we're talking specifically about input and output from a computer using spoken language. Now, there's pros and cons of a voice user interface when compared to, say, a speech user interface, when compared to a graphic user interface, which is what we're all most used to, right? So when we think about voice user interface design and speaking to computers, it has some benefits, like it's optimal for hands-free and eyes-free situations. Right, so if you're not looking at your radio in your car and you want to listen to the Rolling Stones, being able to say play Rolling Stones is fantastic. So you'd want to be able to say that. That's an eyes-free and hands-free situation. That's an extreme example. Also, people are born experts at spoken language. Right, so we all know from an early age how to speak, both in terms of the words we're going to use. We build that up over time, and some researchers suggest that we're born with the basic rules of grammar built in, or at least the tools we need to learn grammar are immediately there. So we're born with those things that we aren't necessarily born with. Like typing is not something that we are necessarily born with, and we have to learn over time. So VUI has those benefits. Of course, there's a downside as well. Right, so if you think about when you hear words, right, it's a serial piece of information. At any given moment, you're getting one singular piece of information. So it's a singular stream. Whereas compared to GUI, you have massively parallel information, right? You could be seeing 5 buttons at once and be able to handle that on a screen, but you can only hear one option at a time with a voice user interface, right? So that's a drawback of a VUI. Another drawback is that it's ephemeral, right? It goes away immediately. After you hear something, it's done, it's gone. Whereas with a graphic user interface, right, it's static and it can stay up for as long as is needed. So one of the messages I hope I'm going to convey during this is that we can't just think of VUI as a better form of interaction, a worse form of interaction. There's drawbacks and there's benefits, and they always have to be paired with some other modality, such as graphic user interface design. And with Jibo, that's very much the case, and we'll talk about that in a moment. So, where might you have seen or heard of VUI in the past? Well, you've probably come across them in many places. If you've interacted with Amazon Echo or Google Home or other smart speakers, you've certainly interacted with it there. If you've ever called a company and wanted to talk to a person but talk to a phone menu instead, you've probably interacted with one there. Also smartphones, if you've done any sort of voice search or dictation, and in the future with Jibo and possibly other social robots. These are different places where you may interact by speech. And right now, this slide you're looking at right now focuses specifically on input modalities as opposed to output. And I tried to enumerate what the different types of input modalities are for these different form factors. They may not be perfect, but it's a pretty close approximation. And as you can see, as we move from the smart speaker over to the social robot, the number of modalities gets larger and larger. Now, that is not in any way to denigrate the design efforts of people working on smart speakers. It's actually a real challenge to work with fewer modalities and make it work well. So having only speech and hard buttons, and somebody pointed out that I should add touch sensors here because you can change the volume on a smart speaker by moving your finger along it. That's a much more limited, narrow band to work in design-wise. So that has its own challenges. But with a social robot, you're also dealing with a whole bunch of modalities, and so designing for it can be another type of interesting challenge. And if we switch over to output modalities, the same thing holds, right? So with a social robot, you have the potential of a speech output, nonverbal audio, which is what we mean by NVA here. Bleeps and bloops and different things that could be Jibo's original language, or just notes that maybe information that maybe you've tapped a button or things like that. Also his screen, body movement, and also his lights. Now, another thing to point out is each one of those checkboxes is not necessarily equal, right? There can be a great range within each one of those modalities. So to give an example, on a smartphone, you could say that it has body movement, right? It vibrates sometimes, right? And so it can communicate something with that vibration. That same checkbox with Jibo is quite a different thing, right? Not only, there's not really the vibration, but there can be many different axes upon which he can move and communicate, right? So the range of each one of those checkboxes can vary dramatically from form factor to form factor, and with each example within a form factor. So this slide has a lot of information. Let me try and make it clear. So the question we're asking here is, what makes a good VUI experience, right? Because you can just slap a VUI onto a product and say that you've met that bullet point, that it uses speech. But you can cause a lot of hurdles by doing that, as opposed to making life easier for your users, right? So what makes a good VUI experience? Well, a lot of things that make a good VUI experience on a social robot are the same as with other form factors. Things that just make VUI good regardless of form factor. These are some examples. So, use ellipsis. In a conversation, when you talk to somebody, you don't say as much as you always have to, because context can start narrowing down what you mean, right? So on the right of this slide, you see a couple of examples of the bullet points. The first table that says system, person, and system, that's a dialogue where you can imagine a social robot or a smart speaker playing Mad Libs, and the system might say, give me a noun, and the person says in response, lobster. The next thing the system says doesn't have to be, give me a verb, right? That would be rather robotic to keep saying, give me a noun, give me a verb, give me an adjective, right? So he can shorten it a little bit and say, and a verb. And then maybe next time, after the person's given their example of a verb, he might just say, adjective, right? So that's a form of ellipsis. And that's what humans do in a conversation as well. So that's an example of good VUI experience, and that isn't just for a social robot. That's for an IVR. That's for, you name it, a smart speaker, it doesn't matter. Use discourse markers. When we talk to people, we don't just say exactly the message we want to communicate in terms of the subject of the conversation. We also want to structure the dialogue in some way so people don't get lost. So you could imagine somebody saying, order a pizza to a computer using voice, and the computer might come back and say, you got it. First, what would you like on it, right? So that first is not necessarily part of ordering a pizza, but it structures the conversation in a way that people don't get lost. It's like a signpost along the way. And there's many other types of discourse markers, like first, second, there's also like well, and so anyway. These types of things are required. Also, you need to write great grammars. And if you're wondering what I mean by grammars, when you say something to a speech recognition system and it has to act on it, some programmer had to go in and create a file that specifies what the system can understand, right? To use the most basic example, if the system says, that's not a basic example, let me think of another one. If the system asks you, do you want any toppings on that, right? A grammar would have to include yes and no, right? And maybe synonyms of yes and no. Like yes might have synonyms like you got it, and sure, and I think so. And no should have synonyms like no way, or I don't think so. But in addition, to write a great grammar in that situation, you don't just want the yes and no, because a person might say yes, pepperoni, or no, olives. I mean, yes, olives, not no olives. That would be weird. So you need to cover all of those examples as well. So you have to write great grammars or else people are going to get tripped up. Another example is avoid jargon. So I had an interesting experience a while back where I called a rental car company and the phone system said back to me at the beginning, this IVR understands speech. So I found that fascinating that they chose to use the expression IVR in their phone menu that was facing all of their customers. That could have been, my mother-in-law. It's an amazing choice to do that. So you should avoid jargon. So use the words that you think people are going to use day to day. Also, ask yes/no questions in the affirmative so people don't get confused. So you don't want to ask questions like, are you sure you don't want to play again? Right? It's very hard to answer that question. Right? What does yes mean and what does no mean? Also, avoid this structure. For X, say X, right? This is an old phone menu structure that has no real purpose. The voice commands that you give as options should be self-evident. So if you want to provide help to a person, you wouldn't have the system say, for help, say help. You would simply say, if you need to, say more information. Or if you need to, say help, right? The command itself is self-evident. You don't need that structure. It's a very old kind of programmatic way of thinking about things. And the covers of the two books that you see on the screen right now, those are two books that I would say are really important if you're going to be doing any voice design. The one on the left by James Jangola and Cohen and Below is really useful. It's not necessarily about social robotics in any way. It predates social robotics. And I believe smart speakers, but a lot of the things that they say there are true to all voice user interface design and are worth taking a look at. And the other one is using language, which is not about computers at all. That's about how people communicate at a conversational level. The little rules that we all follow that we don't even realize we follow. So Using Language by Herb Clark is also an indispensable resource. As another example of what makes good VUI experience is there's going to be errors, right? Speech is not like tapping a button or clicking on a button, right? Or typing on a keyboard. There's a much larger space for error, right? It's a much more uncertain environment. But errors don't have to feel like errors. When we have conversations with people, sometimes things go off the rails for a moment. And a simple excuse me can bring it right back on track. And that doesn't really, you won't even remember that later. And it won't bring down your estimation of the person who didn't hear you. It's very understandable. We all deal with it day to day. And so when a system does it, it should also feel very seamless. Now, a lot of times with old speech recognition systems, you might experience something like what you see here on the left. Like, Jibo does not do the thing on the left here. This is an example of what we wouldn't do. So, for example, hey, Jibo, set an alarm. Sure, for what time? Early. We would not have him say, sorry, I didn't understand. Please say a time. For example, 7 a.m. And then he says, the person says, eating food, blah, 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 blah. And then he comes back with a long, I still didn't understand, and then maybe, type on the screen, right? That's a very, very phone menu-ish kind of situation. Much better would be for somebody to say, hey, Jibo, set an alarm. For what time? Early. And if he doesn't understand, he just brings up the buttons on the screen and says, what was that? Right? So that's much more what a human might try first. Now, if things went further than that and person still was running into trouble, then we may have to give a little more direction. But we try to avoid that situation by, again, moving to another modality to help out. As we said earlier, vui alone is not ideal. You need to pair it with other things, just like GUI alone is not ideal. And when we're talking about a social robot, there's even more to consider. Those things that we've been talking about are voice user interface design writ large across all sorts of form factors. But when we're talking about a social robot with a personality, you aren't just thinking about the user. We've always learned as designers, think about the user first. And that's still true. But there's two people involved in this conversation now, right? There's the end user and there's also Jibo. So you have to think about Jibo's motivations when designing as well, right? So Jibo has a point of view. He needs electricity. He loves the shape of macaroni. He is afraid of porcupines. He needs to avoid water, right? So when you think about all these things, you have to, and he also, has emotions and he has motivations. And these things need to be kept in mind. So the designs you come up with, right, need to take those into account. You can imagine if Jibo's tired as opposed to wide awake, you might want to design differently when he's asked a question. You may want to have him use different words, right? Maybe the speed with which he does something might change depending on those things. Maybe he's nervous about doing some sort of, in the future, at some point, if somebody builds a home security thing, maybe he's nervous about intruders, right? Because that's Jibo, right? So in addition to the end user, you have to think about his character when designing because he does have agency. Now, granted, there are some other types of speech recognition systems that do have agency, but not to the level of granularity we're talking about here. So, for example, a phone menu, you could say, has agency and it has intentions, right? Its intention is to keep people from talking to a human being. But that intention doesn't change over time. That is very consistent. One other thing, and it looks like we have a slide issue. There's another thing that one needs to consider that I don't have in front of me right now, but one other thing that's important is that Jibo also needs to, and this is what we were talking about earlier, he needs to emote with multiple modalities, right? So speech is not the only way he communicates, right? When you're thinking about what Jibo's going to say and you're getting his character across, you don't want to just think about the words. You're going to think about his body movements, right? You're going to think about the sounds he makes. And when we talked earlier about multiple modalities, this becomes very key when designing a social robot, okay? You can imagine him just answering a question, right? Like if you ask, who's the 5th president of the United States, he could just answer that, or he can think about it. He can, look up while he's trying to think about it, or close his eyes and concentrate. His body, he might look down, he might look up, right? You have to think, what would a person do if they were thinking about a question that they had to answer, right? So you don't want to think about one modality at a time. You want to think about all modalities at any given time. And so we have a video we wanted to show you that is an example, and this is just a demo, but notice that when he makes sounds, that's not all he's doing to answer a question. So we're going to give this a shot here. Okay, so I hope you were able to hear that, and I hope you noticed he was answering a question about his favorite Olympic sport. And he didn't just show barbells, he didn't just show a boxer's glove, right? In addition to those things, he lifted the weights, he sort of punched or dodged punches, right? So all of these things need to be happening at the same time, and it's very easy, and I'm a voice user interface designer, and I'll admit that sometimes I only think about the solution from a voice perspective, and I start writing a prompt that will answer the question. But you really have to force yourself to say, in addition to what he's saying, how else can he communicate information? So another question is, why is VUI hard? The reason VUI is hard is that even though we are all experts at speech, we're not really self-aware. Right? We're not really aware of how we talk, maybe because we're so used to it. So the reason the bicycle is on here is because we all, not all of us, but many of us know how to ride a bicycle. But even if you ride bicycles every day, it is really hard to explain how it works and why you stay up on two wheels, right? Not even physicists can really explain how that works. There was recently a talk about this when discussing conversation, but with a different context. But the point being is that no matter how good you are at bicycle riding, it's hard to talk about it. And the way we converse is exactly the same, right? So a lot of us are not even aware of the words that are coming out of our mouths. And experiments have been done where people have said words and had those words replaced on the fly and not even noticed when the words were replaced. In addition, moment to moment, people are saying and rising intonation and stammering, and I'm sure throughout this conversation, or this, I should say, my talking to you, I'm sure many times I've stammered and said and had rising intonation. Hopefully most of the time you didn't even notice, but we all do it all of the time. And it was very interesting when I was doing this research on and talking about ums and uhs and other things people do, having a conversation with my professor about it was extremely hard because we both were going and having rising intonation, stammering, etc. So the point being is that to design a voice user interface is quite the challenge because of this. We have to force ourselves to listen, and I mean sincerely listen, to how people speak and then try and put that into a design. Finally, what happens when you do voice user interface wrong? And I'm just going to give you 3 examples to make the point. The stakes can actually be very high. But this first example, you could write a menu, right? And this could be on a robot, this could be on a smart speaker, this could be in a phone menu. And if you ask, would you like A, B, or C? You're going to get a lot of people saying yes, which is bizarre at first blush. But then when you look at the details, it actually makes sense. Let's say you're using a voice talent, and the voice talent says, would you like A, B, or C? Right? That might communicate a list of 3 choices, but if they say, would you like A, B, or C? Right? That can suddenly come across as a yes-no question. Like, do you want any of these 3 things? And I've seen it happen. In addition, if people barge in and you're saying, would you like A? They will barge in and they will say yes before you've given the other 2 options. So you have to be ready for these types of situations. All of these things have to be taken into account. And they're things you wouldn't have expected, but they happen. The second example, I saw this during a usability test years ago for a bank, right? So the task that people had was to find out how much was in their savings account. And the system said, how can I help? You can say check account balances, transfer funds, or hear other options. And almost everybody picked hear other options, When we asked why, it was because we used the word check in the first one. Check account balances. People thought that would only give them their checking account. Now, had that gone live like that, it could have cost millions of dollars over just a few months for the bank, because they'd have to transfer people from one call center to another, and that piles up when you're talking to multiple agents. So I know that's an IVR example, but the point being is that every word counts. Also, if you ask a question, like let's say you're building a skill that allows people to make a bus ticket reservation, and you say, when would you like to depart? You may not just get a time or a date. You might get people not answering because it may depend on the cost of the ticket, right? So on the larger scale, you have to ask yourself, is the person ready to answer that question? Do they have what they need to answer that question? So at all of these levels, the wording, the prosody, the context in which the question is asked, all of those things are critical when designing. So that's about it. Hopefully this whirlwind tour of VUI design is not too much too fast, but if people have any questions, I'd love to hear them.
Seems like we're a little light on questions today, but take that as you having done a good job. So,
how do you?
No questions.
In Jibo, one question I have is in Jibo, how do you guys prototype voice interactions?
How do we prototype it? Good question. We work internally. We have a person dedicated specifically to designing the prototypes, putting them together on the robot, and then we will usability test with actual users to try it. We will actually build a mini skill. I can't emphasize strongly enough how important it is to put things in front of actual users. Even if you can't get the ideal user, let's say that you know that you've built a skill that is specifically for, I don't know, seniors, for medication, right, and reminders for medication. If you can't get in touch with seniors, at least put it in front of other people so you can at least get some information about what the experience is. Because if you just give it to your friend who knows what you're working on, that's not going to really give you what you want.
Another question from Michael Rodriguez here. One of the difficulties with VUI is knowing what you can say so that you will be understood by the system. How will Jibo help solve that globally and for third-party skills? You can talk globally.
Sure. Well, that's a very good question. The comment I made earlier about good design involves writing great grammars. That's the first pass, right? We are putting all efforts into starting with the best grammars possible that will recognize as much as possible. But then also critical is to review what you've seen and find out, okay, is this, do we have it covered? And again, user testing, user testing, user testing. The more user testing you do, the more likely you're going to come across things that you didn't even think of, right? So, it may be that you say, what's a good example? Hey, do you want to hear an interesting fact about Twin Peaks? Let's say you're a Twin Peaks fan, and you create a skill that does that. You may not have expected for people to say, what do you got? Right? And say, oh my gosh, that's another way people would say yes, is by saying, what do you got? Right? And so you would go back and refine your grammars until you can get that perfect. And that's what we're doing for our skills right now, is we're running it by people, making sure that they can understand. And if what they said isn't recognized, we will keep going back to the well and getting more information about how people speak, as opposed to our best guess.
We have another question. VUI, or voice user interaction, for social robots needs a lot of variability so that Jibo doesn't seem so robotic. Any design tips at all? I know you've addressed some already, but maybe any.
Yeah, I think the answer to that previous question certainly overlaps with that. On these, in terms of input modality, right? So when you're designing the speech user interface and what people can say to the robot, you certainly need to get lots of examples of what people will do so you can get it right and keep refining it. It's iterative, right? You're never going to get it right off the bat. People are going to say things and Jibo won't get it, but you'll keep improving by getting more user testing done. In terms of what Jibo says to people, we make it a best practice to, and it's good you brought this up, we make it a best practice to write multiple variations of any prompt that Jibo might say. so that he doesn't become robotic. So even if it's a question like, how tall are you, right? He could just simply say, I'm 11 inches tall, but we've made sure to have multiple different ways he could answer that question so that it doesn't become robotic.
Another question, actually, which is very interesting. Will Jibo's GUI be able to handle hum by default, or do all rule files need to be adjusted? So listening to you, Minute Bar notices that we tend to use the word a lot.
Mm-hmm.
Not that that's bad; it's a way to communicate.
Right.
Will the rule file? I mean, is that how do you think
Yeah.
designers should?
Sure. Grammars usually involve wildcards that allow for a certain amount of noise, specifically at the beginning and end. So if somebody's going to say yes, if a grammar is written properly, there should be a wildcard at the beginning that can allow for that to be handled. So that's very important because, as you point out, people say and quite a bit, and we need to be flexible around that.
In America, we use the word like a lot, I guess, too.
We do, but what's interesting is Sharon Oviatt, who I believe at the time she did this research was at SRI, I think. Somebody got a sanity check me there, but Sharon Oviatt found that when people interact with robots, or I should say speech systems in general, they tend to use fewer disfluencies than they do with people. So it's a little less often that they say and they stammer a little less. That doesn't mean that they don't do it. They do it at a much, much lower rate per word than they do with people. So it's still very important, but it's interesting that people do it a little less with computers than they do with people.
I had a question which was, do you see voice interfaces as the future of all interactions that we have? Maybe replace on mobile phones?
No, I don't. I think voice user interaction design, voice interaction is critical, but it's one tool in the toolbox. And just as I don't think that a hammer is going to replace a wrench and a screwdriver, speech will just be one extra thing that we can use for certain situations. Like the example I gave earlier about a hands-free, eyes-free situation. Sure, when you're driving your car, a voice user interface can be very beneficial. But if you're sitting right in front of your laptop and you've got a keyboard and you've got a mouse and you've got to do some sort of editing, right, then speech, the motivation for using it is a little less, critical. When I was working at Dragon, we found that people dictated a lot by voice, which made perfect sense. But then when it came time to edit, a lot of people would switch over to using the mouse and the keyboard. And then when you think about it, that makes perfect sense because it's to actually say, select this word, correct that word, now go to this word. To do that by voice is rather cumbersome, right? So it really depends on the situation.
We got a question from Michael, which I think is really good. Have your team considered requiring GUI tutorials with third-party skills? For example, Jibo walking through what you can say to trigger a skill when it's first installed. I think this is more of a suggestion for us to provide guidance, like GUI tutorials to third-party skills, teach them how to interact. And stuff.
Right. So we're certainly working on documentation in terms of VUI and how to design VUI. I can't unfortunately answer the question about specifically around launch rules. Not because it's a secure thing, it's because I actually don't know the answer. I would have to find that out for you. I'm not sure.
Yeah, but it's something that we will definitely advise third-party developers to build into their skills.
Yeah, absolutely.
Yeah. Great. Other than that, I think we're
Good. That's great.
All right.
Thanks, John.
Thank you, everybody. Take care. I hope this was helpful.